All right, so I guess to get back to where we left off on our loops, if you did the exercise, pretty small exercise. So that's how you would create a list, and then just loop through it and print out the people that are in the list. All right. So anybody have any questions on loops before we move on to the second half? All right. Great. Let me make sure this still works. Good. All right. So let's start moving in some of the more of the advanced topics. So the next thing we're going to talk about is functions. So here's kind of a cool example of what we're talking about. So if I asked you how to make a peanut butter and jelly sandwich, and I said you have the option on the left where you need to follow these instructions: get bread, get the knife, open the peanut butter, put the peanut butter on the bread. Or what if I said, hey, you can have a personal chef and you can just tell him to make you a peanut butter and jelly sandwich? So which of these would be easier? Well, of course, it's the one on the right, because you only have to do one thing. You just have to tell the chef, hey, make a peanut butter and jelly sandwich for me. So this is what functions kind of do. They wrap up, and then, because our chef is going to be doing all of these commands on the left that we know about, but he's kind of hiding that from us. He's going to go in the kitchen and follow the recipe. But, I don't really know what he's doing. Like, maybe he's using crunchy peanut butter. Maybe I can tell him what kind of peanut butter I want. But some of that is kind of organized and put off to the side, so I don't have to worry about it. So functions give us a way to group instructions, and that grouping allows us to reuse things very easily. So now that we have the chef in the kitchen, I can tell him make 5 peanut butter sandwiches. That's easy for me. It also, functions allow us to organize things. So we can maybe group a set of things. And so it's also just, for the human, for us to say, this is how I want to maybe put my steps. Maybe you put 5 steps in one function and then another 5 steps in the next function. All right, so let's look at a function. So we're going to go along with this peanut butter and jelly theme here. So if we're going to make a function here, you're going to use the def keyword, which is stands for define. It's just a shortcut for that. Although you can't use the word define, you have to use def as the keyword. And I lost my internet. All right, let's just do this. Okay, it was just up a second ago, but all right, here we go. Yeah, I guess my virtual machine went to sleep. All right, we'll wait a second here. Good. Everyone like lunch? Come on, you can do it. Just make sure my internet is actually working. Okay, internet looks good. Let's just do this. All right, don't die. hopefully they're serviced it in the, so coding.com works off of, here we go, works off of Amazon web services, which there have been outages for the past week. So hopefully we're not getting hit by that right now. Come on. All right, well, let's see if I can talk more while that happens. Okay, yeah, I guess I'll keep talking. So like I said, we use the def keyword. We're going to name our function, so we're going to call it make peanut butter and jelly. And then we can define with our function what's going to be the input to the function. So with this, we're saying bread's going to be an input, peanut butter, jam, and knife are going to be an input into our function. Okay, here we go. Let's see if we can get this back. Okay, so let's go ahead and try this out. And let's get rid of that. Let's get rid of that. All right, so we're going to define our function, make peanut butter and jelly. We're going to give it some inputs. So you want bread. I'm going to just shorten this up a little bit. Peanut butter. Now again, we're going to put the colon because this is creating a block of code. And I'll do 2 spaces in. And let's make a print statement. So I can take my input now. Do something with that input. Okay, so now I have my function. Now you can see when I hit enter, nothing happened because we're just defining that function. We actually haven't used it yet. So now if we want to go use it, a function is called by using parentheses, but we also have to pass in the input arguments that we require. So let's do some wheat bread and crunchy peanut butter. And so now we can reuse that. And since it's defined, we can keep on reusing this function now. So how about wheat bread with smooth peanut butter? Let's see. What if we did, now we already have the plus operator, right? But let's say we wanted to make that a function. We like to reinvent the wheel. So this is like a mathematical function. Add 2 numbers. So you can put, all types of logic in the function. You usually have an input. An input doesn't necessarily, you don't necessarily have to have an input, but sometimes you're just grouping stuff. But normally a function will have an input, and then it will have some kind of output. So now, right now, I'm gonna save these. We can save these exercises for later. Right now, we're just printing to the screen. A lot of times, we want to take what that function is doing. We don't want to just print it to the screen, but we want to save it somewhere. So like we have this cool add function, right, that we just created. But I can't really do anything. I can't save that anywhere because it's just printing it to the screen. So let's change that up a little bit. So instead of printing it, we can use the keyword return. Now what return is going to do is actually, you have an input, right? This will be our output of the function. All right, so let's try that out again. Now, you can see if I run this right now, because we're in an active interpreter, it does the same thing as before. But now, because we did return, we can save this off. You can see we didn't get any output because we're using return. And what's our answer? Our answer is 5. Say you want the best of both worlds. So we want to print x plus y and then also return it. All right, so now that gives us both. We can see the answer, but then the answer is also saved in our variable. So that's what the return keyword is for. So you have some input, you can extract some output, and now we can reuse this. We can stick this in a loop instead of having to retype all of our logic. We can stick it in a function, have maybe a loop, call our function. We can do a lot of cool things with functions. So here's a good example, double number, which is kind of the same thing. So let's do this example. So let's make a function called double number. It only has one input. And we'll do the best of both worlds here. The answer is, we're going to double it. Then we're going to print it so that we can see it. But then we're also going to return it. All right? So now we have a nice little function that we can give any number and it will double it. And there we go. All right, so that's functions. Again, just to review, you call them using parentheses. Your input will go into those parentheses. You can return an output. Sometimes you don't want to. Sometimes it's just that you're grouping instructions. You can display information. And then, like I said, you can return an output value or not. It's up to you, depending on what you're doing. Any questions on functions? Okay. All right. So now we're going to go on to input. So now we talked about input for functions. What I mean by this input is that sometimes you want the user to type in some input. So that's the kind of input I'm talking about here. Now, since this is a basic course, there's a variety of ways you can get inputs, right? You could get mouse input. You could get, if you're doing web development, you could get input from a web form. You can get keyboard input. We're going to focus on people just typing in something into the command line to get input that way. So we had this example before, or an example like this. So let's go ahead and write this function. All right, so let's write our function. And all we want this to do is say hello to whatever the person all right. So we have our nice little function there. And now we can supply it with names. So, hello Paul, hello Jess. But there's a problem. We want someone to really type in what their name is. We want them to, instead of us having to supply it to the function all the time. We want to capture the input of someone. So, and I thought I updated this, but I guess I didn't. This is the Python 2 command. There we go. Now it's Python 3. So in Python 3, we have, how did this happen? I guess, okay, this is the Python 3 example. So in Python 3, we have this nice built-in function called input. In Python 2, it's called raw input. They both basically do the same thing. So we're going to change our function here. Let's go ahead and clear the screen. All right. So this time, instead of taking the input into the function, we want to ask. We want it to wait until someone types in their name. So we're going to say, what is your name? And just to make it nice, I'll put a little colon. Okay? And then we're going to make it do something with that. So we'll make hello, and then say hello to your name. All right, so now, before we were having to input the name via our code. Now it's going to ask us, what is your name? My name is Paul. Hey, hello, Paul. So input is basically, we'll stop the program at that point and wait for someone to type in, and when they hit enter, it will then accept that as the input. So I can run this again. So now, since we're in an interactive terminal, this really isn't too mind-blowing. But once we get to the point where we're putting this in a file and we're running that program, this is how you can stop that program, ask for the input you need, and then continue processing from there. Now let's go back to our add example. Or we'll do the double number example. Now, actually, oops. I want to ask for the input. Okay. So let's ask for the input. Let's say, what number do you want to double? Okay. And then we're going to double it, right? Easy enough, right? All right, so let's see what happens. Okay, what number do I want to double? I'm going to double 5. Okay, well that doesn't make sense. The double of 5 is not 55. So what happened here? Yeah, go. Yeah, exactly. So input is always going to return a string because you're typing in stuff, it's assuming it's a string. So if we really wanted to actually do math, we need to convert the string to an integer. So let's go ahead and change this up a little bit. So whatever input we get, let's convert it to an integer. And I don't know what the heck happened there. Let me restart that. This terminal is kind of going crazy on me. Let's start this again. So I'm going to convert my string to an integer. I'm just going to shorten up this time. All right, so let's see if this gives us what we want. All right, I'm going to put 5. There we go. 5 times 2 is 10. That's what we wanted. So whenever we use input, it's always going to return you a string. Let's see what happens here. If I run this again, and I give it some bad input. So I didn't give it a number. It tried to convert it to an integer. It said, hey, I don't know what the heck to do with this. And you can see we got a value error. So now when you get more advanced with Python, there are methods for detecting these errors and saying, hey, you gave me a string. I guess maybe we can do that. You know, this won't work. Let's go ahead and try that out. We can actually do this pretty easily. So let's get our input. And so I'm going to do something a little I guess tricky here. Oh, actually. All right, well, I'll just this is the easy way. That's going to be too hard. This is how you catch errors. I don't want to go too much into this, but there's a try except statement. All right, so let's try this again. All right, so if I put in 5, I get 10. But if I put in a string that can't be converted, it says not a number. So that's what the try except statement is used for. I'm not going to go into that, but that's how you catch exceptions or errors in your code. So actually, yeah, I didn't do this quite the correct way. So I should have exited the function if it was not a number. So I could have put a return statement there, so that exited. So yeah, it actually did double it. That's why I was getting all that extra output. All right, but that's functions and input. So any questions on input? All right, so let's go into modules. Now, when I talk about modules right now, this is mainly going to be just about the modules that come with Python, or what's called the standard library. And so you can think of a module as, we have functions. Functions are stuff that you're going to write and reuse. But you can, sometimes you have so many functions or so many classes. You want to make a module out of it. So it's kind of a bigger group of things. Maybe you might think of this as a library. A lot of times, it's blocks of code that you can use and reuse in your code. And a lot of times it has like a certain functionality. So like maybe there's a URL library. So that a URL library would maybe go out onto the web and retrieve stuff for you. Or maybe you'll have there's an OS library that interfaces with the operating system. There's a time library in Python. So anytime you have to work with time, there's a library. Anytime you have to work with dates, there's a date library or a date module. So let's just show some of these. If you go on to python.org, if you go down to global module index, this is the index of everything that comes with Python. So all of these modules, you can see there's a lot of them, automatically come with Python built in. So this is the standard library. Let's get rid of that and zoom in a little bit. So let's just go through a couple of these. So random, excellent module. You want a random number. Oop, we don't want that. So now the way you access a module, it's not, random is not in our namespace right now. It's not there. Name error. Any of these standard modules in the standard library, you do import and the name of the module. There we go. All right. So that said, I want to use the random module. Now, we have access to the random module. And if you actually, that's a cool little thing. If you ever wanted to go see how the random module works, that's where it's located on the box on your computer. You could go read that code if you wanted to. All right, so what's some of the things that the random module can do? So this is a cool little command, random integer. Random.randint. So if you need a random number, there you go. What's another cool thing on random? Random choice. So random choice, you give it a list and it will choose a random thing for you. So that's a cool little module in the standard library. Time. So like I said, time. Let's go to that. So again, I don't have access to time yet. I have to import it. So import time. I now have access to time, to the time module. So if I do time.time, this is, I believe, the number of seconds since the epoch. And if you know what the epoch is, that's all right. But basically, this is a way of expressing what time it is in seconds. Maybe a more user-friendly module is the calendar. So let's bring up the calendar. Import calendar. All right, so we have PR month. What the heck does PR month mean? So PR month, you give it a year and a month, and it prints out a little calendar for you. Let's do another one here. Date time is kind of similar to calendar. Another module. So if you do date time, Now, some of this I know because I've been using these modules. Let's go ahead and print that. Maybe it'll give us a little nicer output. So that's the current date and time. So you're probably wondering, like, okay, well, how did I know what PR month was? How did I know time, the do time.time? That's what this doc is good for. So if we go into date time, this will then give us all the documentation of what that module is. So you can see under date time, there's a date time, and it gives you all of, so we could do today. Let's try that. What does today do instead of now? Okay. Does the same thing, but we could also do this. Datetime.date today, so that gives us just a date, not necessarily the time. So all this is documented in this global module index. Let's go over to random. That might be a good one to look at. So let's look at random. And you can see we get all of these nice functions. Random range, random integer, random choice, shuffle. So if you had like a list of things and you want to shuffle them up, nice little function there. So there's really just like a crazy amount of stuff that comes built into Python that's in this standard library. So before you ever do anything, first thing you should do is Google it. Because there's a good chance there's something in the standard library that already does what you're doing. And then later on in the tutorial here, there's also an even better chance that there's a third-party module that maybe does what you're trying to look for. This is all the stuff that you get for free when you install Python. No extra effort needed. It's there. Let's do one more, which is kind of cool. Import OS. So OS has a method called lister, which lists the directory that you give it. So you can see that's all the files in my directory. How about if I do home, my home directory? Well, that's actually where I am right now. Oh, I'm actually Pizza Panther on here. Okay, that's that directory, but what if I go back one? Let's just try home, see what's in there. So OS is a very cool module you'll probably use a lot too when you want to list files and stuff. Do anything with the operating system. Here's a good example. We went over the list. Well, okay, so let's combine this now, this list directory. So you can see when we did this list directory, we got a list. Imagine that. So let's try this again. So I'm going to list the current directory that I'm in. And now I can loop through it and do something with it. So there's all the files in my directory that I'm currently in. So if you can kind of imagine this stuff in your head now, right? You just listed all the files in your directory. Well, what if you could read them in and parse the information, manipulate the files? Starting to all come together here. Another cool library, I won't run through this one, URL lib, or lib. So in that snippet right there, It's actually retrieving that website, so it's retrieving that HTML, and it's returning a response. Actually, I guess let's go ahead and do it. We'll just go ahead and do it because it's pretty cool. All right, so let's do URL lib. Whoa, that didn't work right. All right, so I guess I'll just have to type this out. So the URL lib has this thing called request. And then on a request, you can open a URL. All right, so we're going to fetch the python.org page. Okay, this is like freaking out on me. See if this works. Okay, I guess it worked. All right, so we got this response thing, this response object. We can read the response. So you can see, if we go, let's go to python.org. If we click View Source, it just fetched this page, and you can see this is the HTML of that page. And you can see it printed it out. So actually, let's do this. Let's print it so that it gets rid of all the new lines. Characters. Oops. Okay, let's do this again. Response. For some reason, this terminal is like wrapping the characters wrong. But anyway, I'm just trying to show that it's fetching the page, and what it's printing out to the screen is this HTML. So, Python, really easy way to write a web scraper. You're trying to maybe like search pages on the internet and maybe search for something and parse information out of that page. There you go. There's actually third-party web scrapers for Python, but even just a standard URL lib is pretty powerful if you need to just do some simple stuff. This URL lib.request will give you a lot of power to do stuff. And you can see this is the documentation for that. All right. So now I'm going to talk about objects. Okay, so any questions on this kind of like the standard library? A lot of that was probably magical. Because you just kind of have to learn what the standard library is and what each of those modules can do. But any questions on the standard library? Okay. Hopefully here we're going to get some tools. Finish up talking about these tools, and then start writing some programs, finally. All right, so the last piece I wanted to kind of talk about before we start getting to like actually putting this all together into a file and writing a program is objects. You define objects in Python with classes. Now this can actually probably be like a whole 6-hour tutorial in itself. So I'm not going to kind of go any deep into this whatsoever. But hopefully, maybe if you've had some previous experience with object-oriented programming, you'll maybe recognize some of this. So classes or objects give us a way of like, again, just like we had the functions organizing our code, objects give us a way to organize our code that's a little bit more advanced and a little bit more complex and help us to do things, architect our programs in a different way that hopefully is easier, more intuitive for certain things. So If you think about an object in the real world, we're going to go through an example with a ball. You can describe an object. So if I had like a red ball, you can say it's red, it's round, it's soft, it's hard. And you can also do things with objects. So if I have a ball, I can throw it. The ball can also bounce. So if I throw it against the wall, it bounces. So the correlation to that in Python or in programming with classes is that things that you can do with the object or with that class is called a method. And then anything that's used to describe that object is called an attribute. So let's go a little bit over what that might be. So like I said, we have this ball. There's a nice little fuzzy red ball there. And like we said, it could be red, it could be blue, right? So these are all attributes. And when we're using it in Python, you do the variable dot, whatever the attribute is. And that describes the object. Methods are basically our functions on that object. So we can kick the ball, and right, when you kick a ball, like something's got to happen, right? It's not just describing it. Something is happening. And so our methods are really, just functions on that object. And they usually do things. They execute some commands, maybe change the object, do something, All right, so let's go over an example. So I'm going to go ahead and type this out. All right, so we're going to create, again, in Python, our objects are defined by the class keyword. All right, so we're going to create a ball class. We put our colon at the end. Now again, this is a block of code, so we got to indent it. And let's just do something a little easy here. Now right now I'm defining a method, just like we defined a function. Now this, you may be asking yourself, why did I call it underscore underscore knit and then put self in there? In Python, whenever you create an object or instantiate an object, the first thing that Python does is it calls a special class called a init, which means initialize. And with every method, it has to know about itself. So whenever you're doing a method, the first thing it passes into you is self. So self for this ball will be itself. So that's what, if we ever have to access the attributes from within the class, we use the self variable. So any method that you put on a class, your first argument is always going to be self. All right, so now we want to define stuff about this ball. All right, we had color, and we wanted to say it was red. Okay. So again, self is describing the ball. So self.color is red. And then we had size. Self.size, and let's say it's a large ball. All right. So let's just go with that for right now before we go into more methods. All right, so now, all we've really done is define our class. Just like with a function, we defined our function and then we went and used it. Now we can actually use this class. So let's go ahead and say ball equals ball. So I'm saying take my ball class and create me a ball object. So now I have a ball. Say I get this weird print statement. But let's check my attributes. Okay, I have a red ball. And what size is it? It's large. So right here in this line, those parentheses, when I use those parentheses to call the class, it executed this function. Python will go execute that function when it instantiates the object or initializes it. So now let's say we wanted to change the color of the ball, just like any variable that we had in the past. Now it's blue. All right, and so, okay, what color? Okay, now that ball is blue. All right. So now let's take this one step further. Any questions on this so far? Right now we're just talking about attributes on that ball. All right, so let's take this again. Let's take this a little further. All right, so we're going to say the color is red. And we're going to say direction is just empty for right now. All right, so now we're going to define a method. Call it the bounce method. And we're going to say if self.direction equals up, it now equals down. All right, so let's try this out again. So now what we just did now is we added a method to our class. And we said when you call bounce, if the direction is up, change it to down. All right, so let's make our ball again. So we got to call our ball class. All right. Let's check what our ball looks like. It's got a color. It's got a direction. All right. Let's bounce it. All right, so let's see what happened. Okay, well, nothing happened yet because our bounce was just an empty string. So let's go and change our direction to up. All right, and then let's rebounce our ball. And so you can see, when we bounce the ball, now the direction has changed. All right, let's bounce it again. It's still down because you can see in our class, we didn't actually do anything with it when it's down. So let's go ahead and make it a little bit better. So we got our ball. It's being initialized. Okay, we're going to initialize it this time with down. So it actually starts somewhere. Starts on the floor, right? Okay, we're going to do our bounce method. All right, so if it's up, Direction is going to be down. And then otherwise, direction is going to be up. All right, so we have a little bit better bounce method there. So let's try this again. All right, we got to make our new ball, initialize a new ball. And let's bounce it. Okay, it's up. Let's bounce it again. It's down, and we can keep on doing that. Oh, did I do that right? Yeah, it's going up, down, and if I bounce it again, it should be down. So that's a method on a class, yes. Yes, so if we do ball.weight equals 5, now I'll show you this command. It's actually very useful. When you have a module or a class and you want to know what's on it, you can use the dir command, which means describe, which I don't know why they would use I, but I guess maybe it's directory, I don't know. I always think of it as describe. So here's all the attributes or methods that are on that class. And you can see weight is on there. We didn't add color, so let's add color. So color equals red. Let's do that again. You can see there's now a color attribute. So Python is dynamic. Some languages would not let you do that. They would say, hey, you never initialize these attributes, so I'm not going to let you add an attribute. Python will let you add an attribute even if you never defined it in your class before. If I really wanted to, I could even like tear out that bounce method on the fly, put my own bounce method in. So you can do some really crazy stuff. So be wary of that. All right, so the last thing I want to kind of go over with classes here. Any other questions on classes? Yeah, you could. You mean is the old one gone forever? Or? Yeah. So, I mean, I can do that, or like, actually, let me do that right here. So, like right now, right, we have ball.bounce. Acts very nice. Bounces our ball. The syntax is kind of crazy if I were to do it right here, but for right now, I'm just going to do this. So now what I just did is I overwrote bounce. Bounce is no longer a method. Now it's an attribute of 5. So let's see what happens when I try to bounce it. So yeah, you could do the same thing, though. You could have a function, insert a function there if you wanted to. Yeah. You could change it. Yeah, there's a lot of stuff you can do. So there are private and public methods. So I'm not going to go over that syntax, but you could do stuff like that. I mean, I don't know how like crazy you want to get. I guess it just depends on who's using your code. But yeah, you can. Actually, you see a lot of this in Ruby where they like monkey patch stuff to death. So I mean, sometimes it's useful too. people want to just go in and change your code around, and they don't have access to edit your library. So, but yeah, it's definitely not a thing you want to do a lot of. So. All right, so let's do one more thing on the class. Any other class questions here? They're interchangeable, so you just got to make sure the front matches the back. The only kind of thing, right? So if you have a quotation mark in your string, that makes it easier. Where if I were to do this, right, I'd get an error. So, but other than that, so if you're using a quote in the actual string that you want to print out, it makes it easier if you just use the other one. But other than that, yeah, it's really up to you, whatever you like to use. Yeah. So yes, I'm not going to get into inheritance, but yeah, you can take a class, you can inherit from it, you could override the bounce method, or you could call the previous bounce method and then add some logic to it. Yes, you can do multiple inheritance. Yeah, so that's all available, yeah, for you. And like I said, I mean, with the objects and classes, like that could be probably like a whole course just on that. So, I just want to kind of show you some of it, so that as you go through other people's code, you're going to see some of this architecture. So it's kind of just good to be familiar with it. And then as you get more advanced, hopefully you'll start using it yourself. But maybe, with just this knowledge, you're able to maybe pull down a third-party library and start being able to interact with it. So right now, when we've defined our class, so let's define our class. We've kind of just hard-coded the color red or the direction of our ball into the initialize function. But just like, if I can ever find it here, just like any function that we've done previously, right, we can have input into that function. So let's say that we want it, when you call the ball, to actually specify which color it is instead of having to call the ball and then change the attribute manually. So let's say we have some input when we initialize. So now we can do self.color is color, and self.size equals size. All right, so now when we try to create a ball, let's try to create it the old way and see what happens. Okay, so you can see when we try to create it the old way, it says, hey, we're missing 2 required positional arguments. So that's because when we define the class, we're expecting that you had color and size as an input. So let's try this again. I'm going to red, large ball. So now we can say, hey, provide me with some input. And now on our class, we have that color, and we have that size. Sometimes so like right now with color and size, we're requiring that to be supplied. Sometimes you want maybe an optional argument. So let's do that. And this same syntax can be used for functions too. So let's say direction equals up. All right. Put this in. All right. So now, when you have a keyword argument, so the keyword is direction, and then we have a default. Up is our default. So let's see if our old call that we just did previously works. Yep, that works because we got the default. But we can also supply it with an argument. And so these optional arguments, since they do have a keyword associated with them, and this is really only needed if you have multiple keywords, but we can also supply it like that. And that will give us the same thing. So let me show you that, I guess, in a little bit more detail. Let's make these all optional. So we're going to say, whoa, this is freaking out. Okay. All right, you know what I'm going to do? I'm just going to make this a function so that hopefully it doesn't freak out on the screen here. Because like I said, it's the same syntax for a function as it is for a class init. So we can say color equals red and size equals large. And then we can say print the color and print the size. All right, so I just made a function called ball. I can call it with no arguments, and I get the defaults. I can call it with one argument. So optional arguments are positional. But since they are optional, you can actually put them, and if you use the keyword, put them in any order you want if you use the keyword. So if I use the keyword, I can specify any order I want. Where if I don't use the keywords, it's going to take them in that order that I put them in. So that's optional arguments. Like I said, it actually works the same way on functions as it does on classes. So that's the same everywhere. Any questions on that? Yes. So if I mix the two, so with this, if I were to define this function, that way, it would expect that I have at least one argument, and it's always got to be the first argument. Then after that, I can put them in any order I want, but I also could just follow the order that they're listed at with no keyword arguments, and it would know to just put them in that order. So like if I added another one, I don't know whether it's like smooth or it's freaking out on me again. But if I added another one, it would expect now 2 arguments and then keywords after that. All right, so that's class, or that's an object. We went through this, so we saw that we can initialize it. We can change the attributes dynamically. We can call the methods. Again, the methods are basically like the functions on that class or on that object that do things. We went through this. So let me do one more thing here. So let's create our ball class again. And I think I said this earlier, but anytime you see double underscore something, double underscore, that's a special magical method in Python that usually means something. Eventually, as you get more into Python, you'll memorize some of these. So I mean, you'll use a init probably all the time because you always want to do stuff on initialize. So let's make this a red ball. So I want to show you one more magical method here. So if we create a ball, you can see when we print it out, like, what the heck is that? That's actually the memory location of that ball. We really want something maybe more readable. Like, if I have to print this out in a log, maybe I want some better information about that ball. So let's make this a little bit more readable. So one of the other magical methods in Python is the string method. Actually, let's do this. Let's do so what the string method does is that's called anytime you want to convert something to a string. So when you print out ball to the interpreter, right, it doesn't really know what to do with it, so the default is it says, hey, I'm just going to print out, this is the class name, and I'm going to print out the location in memory. But we want something a little bit more useful. We want to say, hey, if you want to convert this to a string, this is how you convert it. All right, so let's try this again. So we made the ball. You can still see we still have that, but if we do print now, so print is going to say convert this to a string for me. And now that's where it runs that magical method of this is a red ball. So one of the other things, right, if we do type on our ball, okay, it's a ball type. Yeah, that's a class that we created. We can also now use a string function that comes with as a built-in function. There you go. So the string, double underscore string, is what tells Python how to convert stuff to a string for you. And like I said, there's a bunch of these magic methods. You'll learn them as you go along. But the string one is nice to know because a lot of times you'll use that for like debugging stuff. You want to print out the object you're working on, and you want the printout to be something other than this gobbledygook that comes out. Any questions on that? guess just to give you an example of some of the other magic methods. So like earlier when we talked about types, there's an equals magic method, or I mean a double underscore equals. So that tells it how to compare things if you're putting it into Boolean expressions. Say I tried to put my ball in a for loop. There's an iterable magic method that you can use that would say like, hey, if they try and iterate over my ball, what does my ball do? So there's all kinds of magical methods. All right. So any questions about any of that before we actually like write a program in here finally? All right. So now here's what we've been waiting for all day, is how to write a program. All right. So this is where we're going to get out of our interactive terminal. So if you type in exit and parentheses, that's going to bring you back to the command line. I'm going to go ahead and I want the file. Why don't we take a, when does this class go to? Okay. Yeah, why don't we take a 15-minute break? So we'll say 2:30. Take a bathroom break real quick, and then we'll write our first program here. Before we get to this final part of it, any questions about classes or keyword arguments or anything? All right, so basically we're going to go write a program now. We'll actually probably write maybe 2 or 3 quick programs here. And I'm going to go over some of the third-party modules, not necessarily go over too much, but how you can find them, how you can use them. And then I have some exercises kind of for like that last hour. If people want to try them, you can. We'll help you out if you have questions. You're welcome to leave anytime too. So, but all right. So let's go ahead and write a program here. So now, the first program that probably almost everyone writes is usually Hello World. So let's start with that. So in the IDE here, I'm going to create a file. I'll call it hello.py. So normally all Python files, you want to put a .py at the end. So that you know it's a Python file. All right, so I'm going to split this up. What's that? No, I just made a file on the side here, and then I opened it up. I'm going to split this up here. All right, so I have my file at the top here. I have my terminal at the bottom. All right, so let's do our first program. So, I mean, this is going to be really simple. You can see if you're using this coding.com, as I type here, it has what's called autocomplete. What's that? Man, I thought you guys were just clapping for me really hard. Sounds like someone's clapping. But you can see in this IDE they have autocomplete. So as you type, you can actually just select. It knows a lot of the Python standard commands. So it's kind of cool if you don't want to type stuff out. All right, so let's type our first program here. And if you want to type this in, so this is all we're going to do, and then hit Control S for save. It's probably Command S on the Mac if you have a Mac. I'm not certain. All right. So go ahead and put that in your hello.py. So all we're doing is printing that out to the screen. And so let's go down to our terminal here. Just in case you moved around, type cd. So you're back to your home directory. And actually, I'll just do an ls real quick right here. So you can see there's my file, hello.py. All right, so now I want to run it. Now, most of the stuff, or I believe all the stuff I'm going to show off here, would actually run in Python 2 or Python 3. But I'm just going to go ahead and remember that I want to use Python 3 since that's what we did all of our class in. So I'm going to type in Python 3. But now, don't hit enter yet. Instead of going into the interactive terminal, I'm going to give it the name of my program that I wrote. And that's going to tell it, Python, run that program. So let me run that program. Hit enter now. So there you go. There's your first program. Now, this is, you could do this, if you're just doing your own stuff. However, if you want to make this a module, or a lot of times if you're putting documentation into your programs, I want to show you this way of programming or this way of styling your code so that your code is more compatible with other people's code. So normally, if you're doing just a program that you're going to run, you want to follow this standard. And you see double underscore name. Again, that's kind of like an automagical thing that's in Python. And I can show you the difference here. All right. So normally if you're just writing a program that's in a file that you're going to run, you usually want to use this style. Otherwise, your program is not going to be as compatible with other people's libraries. And I can show you why here in a second. So just for right now, this is just a way, remember that you normally want to do this. It's just saying, if we're in the main part of the program, go ahead and execute. So I save that. And there we go, it worked. So let's move this a little bit, organize this a little bit better. Let's make this a function. All right. Hello. All right, so I saved that again. So let's just verify that this still works. All right. So now I'm going to show you why you need to do that if name equals main line. So let's go back into the Python 3 terminal, interactive terminal. And now, just like we talked about before, we had modules. Well, guess what? We actually just created a module. So if I do import hello, we just imported the module that we just created. And if you look at your module, you can see our module has a hello function. So if I do hello.hello, there we go. We just created our first Python module. You could publish this on the web and say, hey, look at my awesome program. It's reusable. Go try it out now. All right, so I'm going to get out of this terminal. Now let's get rid of this for a second. One thing I didn't show was commenting. So if you ever want to put comments in your code, oops, you can put the, I guess today's kids call it the hashtag, the hash mark, whatever you want to call it. If you put the hash on a line, that comments it out. So that's a comment. You can see it turned all green. All right, so let's say that I didn't do the if name equals main. And let me go back into my terminal here, my Python terminal. Now I'm going to try import hello again. Let's see what happens. So like, wait, hold on. It automatically just executed. Because we didn't have this line, it's actually executing when we do the import. We still have our hello.hello. Still there, but we really didn't want it to execute immediately on import. So that's why when you write your programs, you almost always want to use if name equals main, because that will make your code more reusable for other people. So we're going to use that throughout the rest of these examples. So let's get out of that. All right. So let's make this really awesome now. So we're going to use some of the tools. This is going to be the super hello world.py. We're going to use some of the tools that we talked about. So let's do a loop. Ooh, we're going to get fancy here. And let's say we want to say hello to 5 of our friends. So we're going to loop 5 times. And let's push that in a little bit, indent that. All right, now we want our friends to type in their names. So let's get our friend. Let's get our input. Let's say, system, what is your name? And then we're going to give them a custom hello message. All right. So take a minute if you want to follow along, type that out. All right. So let's look at this, if you're typing that out. So we're going to loop through range 5 times. We're going to ask for an input 5 times because we're going through that loop. And then we're going to print out hello and then whatever the friend's name is. All right, so let's try that out. Again, if you're on the command line and you're typing, you can press tab and it will tab complete your program name for you. Okay, what is your name? Cool, all right. My name is Paul. Hello, Paul. Hello, Jess. Hello, Chris. What? You're not paying attention? No, this is fine. It should do it 5 times. Let's do John, Kate. There we go. I did it 5 times. All right, so okay, that was cool. But let's maybe bump this up a little bit more. Make this a little bit more awesome. So let's do friend, and I'm going to put that number in there. So you can see up here I called it I. That's just the index, right? So now, and let me get rid of this for a second. I'm just getting the friend, and let's make a list. Let's collect this into a list. So we start an empty list. Yes? In the print statement? Let me go back here. Go back. Undo. Okay, so right here, so when you do print with the comma, that's just multiple arguments. So it's going to print the first argument and print the second argument. It's not actually, you can see it's not, it wasn't in the quotes. So I'm just saying print multiple things. Now, if I would have done this, it would have been different. But with print, that's saying print multiple things. All right, so, but let's get rid of that. All right, and let's make a list. And so, okay, we got our friend. Let's add him to the friend list. All right, so, and this is one of the nice things about autocomplete. I put that dot on there. It will do this for your code too, because any code that you have open, it'll go through and search your classes and figure out all the attributes. But it knows this is a list, and it will give you some options. I didn't actually show this anywhere. Okay, it's not showing me the right option. But if you have a smarter IDE, it might show you the right option. When you have a list, if you want to add something to the list, you can use append. So I started with an empty list. I want everybody to type in their name, and then I'm appending it to that list. All right, so now, okay, we're done. We got our friends list. Now let's do something with those friends. Let's say if Paul is in that list of friends, print awesome sauce. All right, so let's run this again. All right, so we're putting in, put my name in as the second one, and we'll do a cat in there. Yay, I'm coming to the party. So I'm in that list. Maybe we also just want to print the list out. Let's lower this so I don't have to type in as many. Let's just do 2 friends. I don't like having a lot of friends. All right, so then you can see, now when we just print our list out, you can see we kind of get this. So for us, since we've been working with Python right now, that kind of makes sense, because that's what a list looks like, right? But like if we just had a normal user, they'd be like, "Ooh, what's all this bracket stuff for?" Like, why is that there? So let's make this a little bit more pretty. Let me beef that up a little bit. So let's make this a little bit more pretty, and we'll say for friend. Now this is a little inefficient, but we'll do it anyway. In friends. All right, so now we're looping through that list. And you can see we inputted the stuff, it outputted it. I'm not coming this time, so it didn't do that last line. Can I make this a little bigger? So there you go. There's your super crazy hello world. Any questions on that? We used some input there, so we're getting input from the user. And we just did some print statements and some loops in there. So we're combining a lot of these tools now that we've learned about throughout the class. All right. So if there's no question on that, let's see what else I have. So let's do, the next thing I was going to maybe show is, let's do a file. Maybe you want to get a list of files and do stuff with that list. So I'm going to start a new, we'll leave hello world alone there. Let's do a new one. I'll call it file lister.py. Open that up. Okay. All right, again, we want to start off with if name equals main. That will make our code a lot more portable if we ever decide that we want to reuse it other places. And I'm just going to call my function run file lister. Okay. And I'm going to have a run file lister function. All right. So, I believe, we showed this off in the first half, I think somewhere. We're going to go ahead and use the standard, what happened there? The standard library module OS. So I'm going to import that because I need to use it. Again, another style preference here. Normally, in Python, you want to put your imports at the very top. And then that way, the rest of your program has access to those imports. And normally, there's actually a couple ways you can import stuff. So if we want to import more than one thing, we could actually do it like that. But again, another recommended style is to actually import one thing per line. So import OS, import random, makes it a little bit more readable. But for us, we only need OS in this particular case. All right, so we want to list the directory. So again, let's use some input, some user input on this. So our directory, which directory should I list? Okay, so we're going to have some user input on that. And then Standard Library OS has this nice little function called listdir, right? And our input into that is the directory we want to list. All right. And then we want to loop over the files. So let's print out the file name. Okay. And let's see how that works. Let's clear this. All right, in Python 3 and our file lister. All right. So if you remember, dot means the current directory we're in. There we go. We just got a list of all the files in our directory. All right, so now that's kind of boring. Maybe what would be cooler is what if it like lists the files and gave us the file sizes. So I actually don't remember this off the top of my head. So let me go look it up. I believe it's under path, os.path. And here we go. os.path.getSize. All right, so let's try that out. You know what? I'm just going to copy it. All right, so we got our file. Let's do a little string formatting with this one. So we got our file, and then let's put our size, :size. And paste that in there. Actually, let's make this a little bit more readable. So I'm going to do, okay. All right, so here we go. That makes it a little bit more readable for us. So get the size of the file, and then print it out. All right, so let's see if that works. All right, which directory should I list? There you go. All right, so you can see in here, actually, if you look, like, so we're in our current directory, right? Which is these files that we see on the side here. You can see documents is actually a directory and not a file. So really, this doesn't make sense for directory. So maybe can we detect the different directories? Here you go. os.path. You can check, is that a file? Is it a directory? So let's use, let's put a little control logic in here. So we'll say if file is a directory, print, we'll do the file name, and then we'll say is directory. I'll just make it short, is dir. Again, I'll use my string formatting to do that. And then, if it's not a directory, go ahead and print the size. All right, save that up. And let's rerun that. Let me clear this. All right, which directory should I list? So there you go. You can see config is a directory, documents is a directory, bash history. Okay, that's 255. So size is in bytes. Hello Pi, there we go. That was 288 bytes. All right, we're going to really kick this up to the next level next. But any questions on this so far? I'll give you a minute to catch up here. If you want to type it out. I'll run a couple other examples while you're typing it out. How about what's in home? Not file not found. Okay, that's probably a problem. Should I have done that? Nope. I guess it doesn't like me doing that. Let's try. I think that's permissions, right?
Because when you're listing your files and checking the files, it's looking at the current directory.
Oh, I'm not getting the directory right.
Taking the name of the file.
Yeah, okay. All right, so yeah, we should fix this, actually. So it's not getting the path right. Again, this is a nice little thing that Python does for you. So if we want to get the path right, so in os.path, there's another thing called join. So if you want to take a directory and add a file name to it, so normally, right, you would just add a slash. But if you want to make your stuff cross-compatible for Windows, Mac, Linux, os.path join will put the correct separator for your path locations. So you actually should always use that if you're creating file paths. It'll make your stuff run on PC, Mac, and Linux. So actually, we want to take our directory and we want to join the file name to it. All right, so let's see if that fixes it. Yes, there we go. All right, so we got a correct full path there. So let's try that again. Do my home directory. You can see, there we go. And you can see we're getting the full path now in our listing. Let's just go have some more fun here. See what's in documents. And there's nothing in documents. And you can see if I open up my documents here on the side, there was nothing there. Let me put a file in there just to see if our stuff is actually working. New file. All right, so let me run that again. Yeah, we got one new file, and it's an empty file. We didn't put anything in it. All right, so any questions on that? This is just listing some files. You know, if you think about this right now, you could go open these files, look for stuff, manipulate stuff. You know, this could be really powerful. All right, but we're going to kick this up one more notch. So right now, we just listed what's in that current directory. What if we wanted to list what's in that directory and then keep on recursively following down every path that's underneath that? So you're probably thinking that's pretty hard. But again, Python, not so much. It's really easy. So if we go back to our OS here, module, let's see if I can find it. Again, this is all the stuff that's in OS. So it's a lot of stuff. We're getting closer. Maybe I just search for it. Let's see. I'll just do a search for it. Here we go. So in OS, there's a function called walk. And this, you give it a directory, it will walk the directory down all of the paths that are underneath of it. And if you kind of scroll a little bit here, you can see it gives a nice little example of how it's supposed to work. So I'm going to copy that. All right. And all we're going to do is modify this just a little bit. So I'm going to copy that. Take out this thing. Put our directory in there. All right, so I swapped that out. So in here, you can see os.walk returns a root, it returns directories, and it returns files. So it actually separates it for us. So we really don't need this if statement that we did anymore. It's separating for us. So let's do a loop through the directories. We don't need this, so let's move it up here. Now I'm going to make a thing called full path. So again, we're going to use os.path.join. So root is the root of our directory. Actually, I should move it down here. All right, so we're going to do root, and then the directory that we're looping through. And then we're going to do the same thing now for file. So again, it already split it out for us. It already has the files, it already has the directories. So let's loop around that. We can get rid of all this now. Let's copy this down here, this full path. All right, so now let's look at this. It's actually, I think it's actually less code. Yeah, we can get rid of this, right? So actually, fewer lines of code, and we're actually doing more now because we're recursively going down a directory. So let's try that out. All right, so we're going to run file lister. Let's just do the current directory. I must have got the path. Oh, I didn't change that correctly. All right, here we go. Let's try that again. All right, so you can see now, it's not only going through our current directory, but it's looking through every directory that's underneath of that. All right, so let's go a little bit crazy here and make this bigger. All right. And let's list every file on this machine. So we're going to do slash. is now going to just go through our whole machine, our whole virtual machine, and list everything possible. So that will keep on going for a while. How do I get back here? Here we go. All right, so that's the file lister. All right. So any questions on that? This is just some example programs that I'm showing off. So, and some examples of the standard library. And that will keep on going until it goes through all the files on the system. So, I guess the last kind of piece that I want to talk about. So we did OS, and this is a standard library module. And I showed you this already. These are all of the standard library modules. Actually, I probably should go through and count these, but you can see there's an immense amount of standard library stuff. But in addition to that, there's also third-party modules that people write, that you're going to write. So, like I said earlier, before you go do anything hard, Google it and see if someone wrote it already. There's a good chance that someone already did. You can really place these modules anywhere you want. I mean, a lot of people you'll find like stuff is on GitHub now. But where the Python community places their modules is on PyPy, it's called. So let's bring that up. So you can see this is the Python package index. It's not too hard to package stuff up. So you can see already when we wrote that hello world, we were able to import that. There's only one extra step now. You have to create what's called a setup.py in order to upload this to the Python package index. So it's really not too hard. You can see here, that's a list. So this is all just today of people uploading modules to PyPy that does all kinds of stuff. Yeah, this is all just probably this afternoon. So like I'm a web guy. I like using Django. The search on PyPy isn't too good, so usually it's just easier to Google stuff. But here you go. If you want to do web work, here's Django. And here's some documentation. So actually, Django has some good docs. You can go learn it. I don't know, anything, probably just about any topic you want, there's a Python module and functions for it. Let's see. All right. So now there's one problem, though. You have to go get these functions or go get these modules. On your Mac and PC, it's going to be different. The standard tool to download these modules is called pip, which is the Python package installer or something like that. We can run this on our virtual machine. It's actually really easy. So let's run it. If you're on a Linux system that has apt-get, you can run this command. Okay, it looked like we finally finished running through our, it looks like it errored out on something, but it finally finished our file lister there. Yeah, well, it looks like it had a actually, I don't know. Yeah, it looks like it had a non-Unicode character. So something just didn't like, it must have had a weird character or something. Yeah, I thought that shouldn't happen in Python 3, but you know what I bet it is? Yeah, it's because of this right here. So if you put a U in front of your string, it means it's Unicode. That's a whole nother topic, so if you want to know about Unicode, ask me after the session. All right, hold on, let me make up a new terminal. All right, we'll let this go here. All right. All right. So installing a package. So you have to have this tool called pip. So let me paste that command line. Okay, I guess it didn't. I think my file lister is taking all my resources. These are very small virtual machines. So whenever you run anything, I'm going to kill this for right now. There's not too many resources. However, it's actually a good thing because when you're programming, a lot of times I program on a virtual machine, and so I'm the first one to find any memory leaks. So, come on, kill it. All right, I'm just going to kill the terminal. Kill it. Come on. Yay, there we go. All right, let's try this again. See if we can get pip installed. Oh, no, it's still running it. Terminate. There we go. All right. So if we want to install pip on Linux, and we're using Python 3. There's actually another version for Python 2. Yes, I want to install it. All right, so this is going to install pip for me. Let's let this finish. Now, once we have pip installed, any of these packages that are here, so let's take again Django, for example. You just do pip install and then the name of the package. All right, so we have pip installed. Again, we want the Python 3, so we're going to do pip install or pip3 install. And I want to install Django. So you can see it's going out to PyPy. It's downloading the package. Okay, so actually I forgot something here. We have to be administrator to install this package. So I'm going to run this as administrator with sudo. And so there it goes, install Django. So now, if I was doing web programming, I can do import Django, get all the Django functions. There's really a ton of packages. Requests is a nice, I actually already have this, but requests is a nice URL library for making web requests. There's millions of things in PyPy. Again, Google it first and see if you can find somebody who's done it. If you're on a Mac or PC, sometimes some of these packages have binary code in them that needs to get compiled when it installs. And it's hard for that to happen. So if you run into that case, some of these other talks, tomorrow you might hear about like Anaconda or I forget what the other one is now. But some of the scientific guys and Continuum IO, which is here, they're a sponsor, I believe, they write another packaging tool that's like pip that lets you pull down packages. Pip is usually the most up-to-date since it's the official Python community package manager. But Continuum has a nice GUI to it. So if you want to install stuff like on your local machine, So yeah, that's called Anaconda. There's another one too. I forget what it's called now. But there's some other kind of nicer ways if you're on a Mac or PC to install stuff for these third-party packages. Yeah, actually, this is another cool one, Arrow. I've just been using it lately. So, like, working with date times can actually be really confusing. This Arrow package makes it a lot more easy to work with date times and manipulate stuff. And it has time zones and different things built into it. So any questions on third-party modules or any kind of modules you're looking for? Maybe I can know if they exist already, if there's a specific area of interest. Anyone have anything they're looking for? I don't know off the top of my head, but I could almost guarantee you, yeah, there's something in there. Yeah, because it's so commonly used that, yeah, I would, if that's not in there, I would be surprised. Let's see.
I think usually you have like a library of specific functions. There's like geo libraries where you ask like how far apart are two places on a globe, and those usually come with ways to input different units into the data type.
So actually you can see, again, this is more of a web package, but you can see, so this is something like I might use, Django units, convert units between different systems. But yeah, like Chris said, I've used like some geographical packages that actually already have that conversion built into it. And a lot of these will have like a homepage link that you can click on, and then they'll show you how to use it. So they'll give you some docs. Any other questions on modules, third-party modules? All right, so congratulations. You are now considered a Pythonista. I put some exercises. So I put a link here, practicepython.org. There's actually a bunch of exercises. I went through and kind of figured the ones out where we talked about a lot of the tools to actually go do them. So here's a list of things I think you could go do. Pretty easy with what we talked about today. Some of them are harder, some of them are easier. There's more examples on there. So if you really want to like start going hardcore Python, yeah, go through all those examples. I'll be hanging out. I'll probably go get some water here, but I'll be hanging out in the room if anyone has any questions. But that's really all I'm going to talk about today. So thanks for coming.